Construct graph or cut to compare relative frequency and cumulative relative frequency in each dataset. First, create data class and calculate the frequency according to class for domestic and international. After that is for domestic data, to get the relative frequency, each frequency divide total frequency to get relative frequency for each row. Example 0.042, and here I take 3 decimal point and so on for every row. The cumulative frequency is calculated by adding each frequency from a frequency distribution table to sum of the frequency. After that, construct combination graph to compare between relative frequency and cumulative frequency for domestic data. And the international data is same like before, is frequency divide total frequency, and for cumulative frequency, same like domestic data, calculated by adding each frequency from frequency distribution. C is international data, using combination graph to compare relative frequency and cumulative frequency for international data, and using histogram and OGIF graph.
Greetings. So today I'm going to present about my group assignment for this semester, which is the course code is BT12703 and the course name is Data Analytics and Business Intelligence. So I will present about this particular assignment that have been provided by our lecturer is about airlines and the domestic passenger and international passenger. I'm going to explain about part 2. So part 2 is about calculate and compare measures of central location in each dataset. Okay, we're coming back to our dataset. So part 2 is calculate and compare measure of central location of each dataset. So the first one I will count about the mean for both dataset, which is domestic and international. So I will sum everything that I have here in this dataset and then divide it by 24 because we have 24 airlines here, and we will get 22,618,195, and then I will divide it with 24 and I will get 942,424.79. So this is the amount that I get for the mean in domestic, and then this one is for international. It's the same way as this one before. So I will sum everything and divide it by 24, so I will get 10,945,618 divided by 24, and I will get 456,067.42. So each dataset for domestic and international passenger have 942,434.79 and 456,067.42 mean respectively. International have 486,357.37 less passenger than domestic. The second one is the median. So as I write here, as I have written here, is rearrange the dataset from lowest count to the highest count. So this is the arranged dataset, and I have prepared, sorry. So we have 24 dataset here. So that means that we are going to have two median. It's number 12 and number 13. It's for the Japan Airlines and the Korean Air. So I will take these two value of dataset and then sum them up and then divide it by 2, and I will get this 645,979. So this is the median for domestic. And then the second one is international. It's the same way that I have did just now. I rearrange that. Then I will take number 12 and number 13, which is Japan Air Asia and Japan Asia Airways and Japan Airlines. So I will sum this both and then divide it by 2, and I will get 88,666. So the median for both domestic and international passengers are 645,979 and 88,666 respectively. Okay, and the last one is the mode. When we look back at this dataset, I believe everyone knows the answer, right? The mode, we don't have mode here because there's no repeated dataset for both of this list. So there won't be any mode for both datasets since the dataset provided have too many data. No data that have the most frequent occurring value. Every dataset have different amount which leads to the absence of mode in this data. So there's absence of mode. I guess that's all. Thank you for your attention.